Yeah, so I'll talk a little bit about my career and how I kind of got to where I'm at and how I got to New Mexico. And then talk about a little, you know, kind of some of the broad topics on how we stream the Super Bowl. And we got another one coming up next year, so we're gonna have to do it all over again. So, right now I'm currently located in Albuquerque, New Mexico. I've hobbies I've loved to do photography and film photography. Um, right out of college, I moved to New York City literally the day after I graduated. I just took all my dorm equipment and packed it up and went to a frat house in New York City where I lived and found an apartment. So um, I hit the ground running. Um, Nowadays, in addition to just learning all my technical things, I like doing some of the things I never really got to learn when I was in New York, like owning cars, welding, metalwork, that kind of things. I recently started to learn how to rally drive. I took some rally driving courses last year, which has been really fun. And got married a few years ago and just had a baby a month ago. So that's my life now is taking care of babies. Yeah. Um, Bentley College, yeah, it was called Bentley College back then. I graduated in 2009 with a BS in CIS. And I don't know if it's still around, but they had a liberal studies major in media arts, which I also double majored in. I was also in the Deke fraternity. I think that's still around. So, that's a picture of me graduating from the crummy 320p live stream from the ceremony. So, I kind of snagged a screenshot of me. I gave myself a thumbs up there. So, that's what I looked like back in college. Um, so far, I've mainly worked in the entertainment industry my whole career. Um, while I was in college, I had two internships, one at GE Aviation, where I used ancient computers to test jet engines. And then during the financial crisis, I got an opportunity to work at Fox in New York City, as a web video intern. So that was basically uploading small clips from on air to the website and coding some small websites. I really had no idea what I was doing. So that was quite the experience. And then I actually managed to snag a job um, at the end of that internship before going into senior year. So um, it was kind of cool to have a job graduating, but it was not a well-paid job to begin with. It was not for a lot of money. Um, So the first few years that were rough. I was in New York City and I became a junior web engineer. And then my time at Fox, I became a regular engineer, just a, run-of-the-mill engineer, building websites, blogs, Facebook pages. Facebook had just come out and yeah, basically installing some of the first Facebook pages out there for some of these brands and companies, and building some of the websites that they would throw to on air to promote things. So then in 2012, I decided I wanted to jump on the AMC Networks bandwagon because they were at the top of their game. They had shows like Mad Men, Breaking Bad, Walking Dead, and I really wanted to be a part of that. So I joined them to kind of work on their websites and kind of moved up through the ranks there for 7.5, 8 years. Starting off as a web engineer, then becoming a lead engineer, then becoming an engineering manager, and then becoming a director. Um, and then I moved to Albuquerque, New Mexico, to kind of get away from New York City. And so I spent 13 years in New York City, and then yeah, the kind of return to work thing happened during COVID. So I had to find a new hybrid remote role and went back to Fox. And now I'm an engineering director at Fox and help out a lot on Fox Sports and Fox Local technology and architecture. So over the years, these are some of the things I've worked on and built and ran and contributed in all different kinds of ways. All the major network websites and apps, the Fox local apps, most recently the Super Bowl for Fox. I was kind of one of the leads on AMC Plus, which was their streaming, AMC's streaming SVOD service. And yeah, ran a team of about 30 to 40 engineers, program managers, product managers, etc. So now at Fox, I'm kind of a technical program manager, and I'll get to that in a second of what that is. So yeah, that's kind of where I'm been at so far. So that's 15 years out of graduating from college, and trust me, it goes by faster than you can ever imagine. It feels like just yesterday I was at Bentley. So Super Bowl. Coming into this, I'd run some big streaming events prior to me joining Fox, rejoining Fox. At AMC, probably the biggest event I would work on were the Walking Dead premieres. And that was at one time bigger than the NFL. It was a pretty big show, circa 2016, 2017. Which would get 1 million or 2 million concurrent streamers. And I kind of cut my chops on learning how to scale there. So taking all that knowledge and working with a great team at Fox, we kind of, started asking these questions about a year out from the Super Bowl, right? This is something you prep for a year out, right? So CBS is broadcasting it in a few days. They've been prepping this since the day after we finished, guaranteed, because it's the largest streaming event in the United States, not globally, but in the US, and you've got one shot. And if you screw it up, well, everyone will hear about it and know about it, right? So some questions that, we ask internally is how big is it going to be this year? Will our current system that we have scale to meet the needs of how big it will be? How many people from within the company need to contribute to it, right? Fox, I don't know the exact number, but I'm sure Fox, as in total, just Fox has over 1,000 web engineers and, app engineers, infrastructure, et cetera, across all the different units. How many of those folks are we going to need to pull into this, right? How many teams are we going to need to work on it? How are we going to make the app bulletproof to load for everyone at the same time across the United States? How are we going to make sure the live stream plays for everyone at the same time? And how are you going to architect this system to be stable and have lots of redundancy? And then the biggest question is, how do you prepare and test for this before it happens? You can build anything you want all day long, but if you're not sure if it's actually going to do what you think it's going to do, then it can be pretty nerve-wracking. So, we started all asking these questions and start forming teams internally within the company to kind of start tackling all these. And I kind of tackled a big portion of these, right? How do we make sure the app loads? How do we make sure the game plays? And then how do you architect the system to be stable? Kind of my main goals as a director of engineering and a technical program manager on the project. So I'm not sure if they teach a lot of this in school, but some things that I learned kind of on the job over the years. I mean, a lot of these positions didn't even exist when I was in college. They exist now, and these kind of make up a team structure for a digital organization, right? You've got your engineers, your product managers, your program managers, your site reliability engineers, your DevOps, and your QA. In addition to your designers and business analysts and data engineers and data scientists and marketers and whatever. But, just in terms of building a platform that's going to stream a live stream, what are the kind of core pieces here? So I'll just kind of run over all these because there might be some terms you're not familiar with. Engineers, obviously, the coders, the guys who the guys and gals who write the apps on the front end and on the back end, right? They're the app developers, they're the API developers, they write the code to deploy the code. They you know, code the design in, they, write the tests, etc. Product managers, they are kind of like the owners of the product, which the product in my company is, the end user client facing apps that you all use. You download an iPhone app, you download a Roku app, you download a Fire TV app, right? Those are what they own, and they have to make sure that there are features and components that are usable and improve the experience for everyone that uses it, right? And they usually define what's called stories, user stories, to tell the engineers what to build in their vision, right? And in some orgs, they're responsible for the bottom line if that feature makes a product or makes a profit or makes a loss. Program managers, they kind of sit across all these different disparate teams and kind of organize them all. And I think they're ultimately responsible for the budget and what teams work on what on kind of the broad scale. This is kind of where I fit in, this is kind of like a new role within digital organizations, which would be like a technical program manager. So I'm kind of like the cat herder, the glue that keeps all the engineering and product and program and project teams together from a technical standpoint, right? Making sure all these different teams are all building things that are going to work together and all have the complete vision from the engineering side. So then you have SRE, which is like site reliability engineering. They're the folks that keep all the systems running, right? We've got Fox Sports has live events, not just during the Super Bowl, but every day, right? Are the streams up? Are the games up? Are they up on time, right? Are the apps loading? Is everything working, right? That's their jobs, right? And their jobs are to kind of help with scaling out the infrastructure to meet the demands of the load that's happening, right? Then you've got DevOps and infrastructure, which these are the engineers that are responsible for setting up the servers and the deployment processes, and architecting how all these things work, security wise and scaling wise. And then you have QA. They're the ones who are responsible for making sure everything is built to spec and that it works the way it says it should work. So they do a lot of testing, automated testing, manual testing, etc. So we formed a team of all the best and the brightest from all the different internal teams we had to make up kind of this larger team, right? So overall, this would be about 100 people. It's hard to count how many people actually contributed, but let's just eyeball it at around 100 people making up these different columns here. I just explained this. So this is kind of what I do, right? Overall system engineering. I need to know how every single system works. So that's, how the streaming works, how the HLS files load, how the CDNs are structured, how the DNS is set up, how APIs are configured, how do they scale, how do they cache, what APIs talk to what APIs, how are the apps consuming each API, how are the apps loading, what's the load order of the apps. Everything you can possibly think of, I have to kind of understand because I need to know what teams need to work on it or what teams need to fix it, that kind of thing. I also communicate up the engineering status with executives. So, something broken, did something fail on a test, that kind of thing. And yeah, internally known as the cat herder, chasing down engineering orgs and engineers. So kind of looking at that first question we posed, right? How big is the Super Bowl going to be? Well, this is actually a chart that was created afterwards, but imagine we don't see this right-hand column here, right? Um, we know each year the Super Bowl gets bigger than the previous year. So every year, each company that runs it has to do it bigger and better than the previous year's company. So we knew going into it, NBC, they had put a lot of their streamers onto Peacock, and they got around 6 million concurrent watchers. So we knew it might be a little bit bigger than that because Fox is actually free when it streams. Unlike NBC was gated, so that means that they have a username and password you got to put in to watch it, right? You got to sign up for Peacock. So to watch the 2022 one. So we knew that's a little bit of friction, right, for getting people to sign up. So we knew it would be more than that because it's always more than that, but we knew it would be even significantly more. And you can kind of see it was a little bit of a drop off between 2021 and 2022. So going into it, we knew it would be more than 6 million plus. But how much? Who knows? Each year is different, right? I'm sure CBS right now, which is preparing for 2024, is expecting 8, 9, 10 million, right? So that's what they're building their system to. So we knew it would be between 6 million plus concurrent users, right? To give you an idea how big that is, at the time, I believe the most watched, and these numbers are way off, but I'm trying to remember the exact numbers. The most watched TikTok video was like 1.3 million concurrent, and the most watched YouTube live stream was like 1 million concurrent, right? So we're talking, huge amounts of scale beyond what everyone might consider like, the creme de la creme of streaming that you all intake, right? So no easy feat going into it, knowing that every time we do this, it's going to be the biggest event ever, right? This has since been broken by, I believe NBC's Peacock did an exclusive football game on Peacock, and they went up into like the 20 or 30 million. So this record's already been smashed in the last 2 months. So if you break down what you actually have to do for the Super Bowl, right? There's two things you really need to accomplish for an end user. You need to get the app to load, and you need to get the stream to play, right? That's all that matters. We don't need your personalization or favorites to load. We don't need, all those other supplemental things that you might experience in an app to load. That's all, cherry on the top if you can, but no one's going to care if, they like a favorite and it doesn't go through. They care if the live stream loads and they can watch the game, right? So these are the two goals of just how are we going to do this, right? So keep these in mind. Internally, after we had looked at these numbers here, at the same time we were kind of prepping for the Super Bowl, what made it a little difficult was we were also broadcasting the World Cup, right? And this is with like Messi in the finals, right? So we kind of knew what the quote unquote tipping over point for our current system is, right? Fox Sports has a system that runs all the time, right? And it can take a certain amount of users the way it's built, right? It's built to kind of scale and support, something that we do day to day, right? And actually, it's been running probably since 2017, the same system, right? It's been running for 6, 7 years. So it was built to handle what it was built to handle. But as we got into the World Cup, we started to realize it's not going to handle this number here. So, right at the end of the World Cup, believe it or not, the system, this it was like 3 minutes after, the final goal kick of the final, like the system collapsed. So we were like, uh-oh, this isn't going to work. So we need to kind of like build out a kind kind of a temporary system that's going to support the Super Bowl at the scale we need, right? Going into this year, it's not going to be the same. We've redone everything, right? So this shouldn't be an issue going forward. But at the time, we're dealing with kind of an ancient system, right? Most web systems last 3 to 4 years if you are if your org is good about maintaining it. So just to give you a lifespan of how long things last. So this one had been going for quite a while already, way past its end of life. So we designated internally something called SB5, which was going to be our new kind of temporary solution to keep the Super Bowl running, right? So it was built different than our every day-to-day system. Some tenets we wanted to keep in mind, right? It's got to be simple, scalable, and stable. Kind of the simplicity behind it. We wanted to remove any excess calls that weren't needed, right? When we're talking about 7 million concurrent people, if you have 7 million people making an extra call, that's like an API call, that's 7 million extra API calls a second that you're dealing with, right? And that just, that grows, right? So let's remove any of the input output that we don't need, right? That could, Fox was free, so we don't need logins. We don't need favorites. We don't need personalization. We don't need continue watching, right? Also, this is one event. And we know down to the minute, basically what the app is going to do. So let's try to serve as much static responses as possible. Static versus dynamic. Static being like it's a rendered file, right? It would be uploaded to a S3 bucket, for example, or served from a CDN, right? You serve a JSON object, and that's it. That's all it needs to do for everyone across the planet. Dynamic being, okay, you log in as Joe Smith, you're going to get Joe Smith stuff, and it's going to render a unique response for you, right? Something dynamic in these kinds of situations would be very expensive, and maybe even beyond the capabilities of any of the service providers we use, right? And then on the user experience side, boil down the app to what people are there for. If you're loading the Fox Sports app on the day of the Super Bowl, you're not there to watch like college wrestling. Maybe you are, but maybe it's just like 10 people on the planet, right? Everyone's there for the Super Bowl. So make the app just load the Super Bowl that one day, right? So we have a lot of tricks that we can do to do that, right? To make the app just do one thing when we need it to. This is a screenshot of the website the day of. You can see the website, which was foxsports.com and fox.com, just did one thing. It loaded the video player. So we actually just used some DNS trickery on the domain name to kind of just point temporarily at what we wanted to serve people, which was the video player and an HTML page, right? With a few of these kind of other systems here, like the matchup and odds, but we knew a lot of people aren't probably going to click on them. They're just going to want to watch the mainstream, right? So this was the goal, right? So we actually took the entire domains on the web, pointed them at this one thing. And on the apps had a feature flag, and we just turned that on. And then the app just rendered out the video, right? So you open up Fox Sports, boom, Super Bowl. And then after the game, we can put the DNS entries back pretty quickly within a few seconds, and then feature flag back to the way the apps used to work, right? So we're literally switching between old system and new system within a few seconds, letting everyone watch the Super Bowl in the new system, and then switching back to the old system, which it only takes a few seconds. So scaling, one of the goals is how high can we get this, right? How can we scale? Even just static endpoints need to scale, right? The live streams need to scale. We did have a few dynamic endpoints. I'm not going to say we didn't use them. Actually, the main video endpoint, the main API call that served the video was dynamic. And I'll explain that a little later on why. So we had to use a bunch of other techniques to scale, right? We had to use kind of server-side caching, right? Memcache and Redis, which are in-memory caching. That's like saving things in memory is the best way to say it, right? Increasing the server size, right? Most of our day-to-day systems use as cheap as servers as possible, right? We don't want to run huge servers that cost a lot all the time, because then you lose money, right? So for this day, though, we were going to go big, right? So we're going to up the size of our server instances, which would be called vertical scaling. Then we're going to increase the amount of servers, right? Day to day, we might have 100 EC2 instances on AWS, right? We're going to have to go up to a lot more than that. Let's say 4,000. And that's just for one API endpoint. It's 4,000. It's even more than that when you consider video and everything. We're talking tens of thousands of servers. We're also going to need those servers in multiple places, right? Most of the year, we just serve out of one place, which would be US East 1, AWS, North Virginia, right? If anyone's ever played with AWS, that's kind of the default place Amazon Web Services, that's kind of the default server availability zone that servers come out of. But if that goes down, then what? Right? We need to have another one. So everything is replicated to US West 2 as well. So we have multiple regions where these servers exist, right? And we use something called an active passive, which would be, the East Coast servers are actively serving everything with the West Coast as a backup. So if the East Coast goes down, you just flip a switch and it goes to the West Coast. And then we also have multiple CDNs sitting on top of that, which would be a content delivery network. There are all kinds of CDNs out there. You might have heard some of them. There's Limelight, Akamai, Cloudflare. You just Google CDNs. There's dozens of them, right? But CDNs can go down, believe it or not, despite how powerful they are. There are millions and millions of servers, right, globally. And they can go down too. So we need to have multiple CDNs serving. And we did an active-active approach for this, meaning we have multiple CDNs serving you the APIs at the same time, right? We have, we actually have a service that splits traffic evenly between them all. So for our video services, we had 5 CDNs running, and we had a service on top that would basically decide which CDN should you get this response from, which CDN should you get this HLS file from, the live stream. And believe it or not, one of the CDNs during the Super Bowl went down. I won't say which one, but we had to set it to 0 traffic and boost the other ones up because it started to fail. So yeah, having lots of backup, right? And this is a picture right here of kind of explaining the multi-region here. And you can see, AWS, I just grabbed this online. AWS has, two server clusters in the United States, East Coast and West Coast. There's actually a lot more. Those are just the big ones that have most of the features. Third point, stability, right? Once you get everyone into the app and they start watching it, you got to kind of keep it going, right? And it's got to stay that way so we're not just talking about 7 million people over 5 minutes. We're talking about 7 million people for 5 hours, right? So we need to make sure that all the caches have long cache times, and they'll always serve a response if some of the other systems go down. So there's always redundancy and backup on everything, right? Multi-region, as I said before, would act as a backup if a region went down, and multi-CDN, right? As I just explained, like We can remove bad CDNs from the pool of CDNs if one goes down. Um, and then obviously as the game is going on, we're constantly running tests across, multiple services. We had every app up on a television screen, right? Is the app stream playing there, right? We've got tests running from different parts of the country, right? Because the stream might load for someone in Boston, but it might not load for someone in New Mexico, right? So we've got monitoring and testing up, basically seeing if everything is working, right? Um, and then backups for everything. Do I have a screen here on backups? No. When I say backups for everything, backups for everything. We had main team in Arizona. We had backup team in LA. We had backup power generators, backup internet. A few years before I rejoined Fox, they actually were doing a test for the 2020 Super Bowl. And during the test, they lost power. They were running it out of the LA lot, the studio, 20th Century Studios. Something that you never even consider is the power going out, right? So that was all taken into account this last year. Right? Internet going out. What happens if the internet goes out while you're running the game? Then what? Right? So we had like wireless hotspots. We had different providers. We had reps in the room from every single company that we were using to help support us, right? People from, I'll just mention a few, like people from Google, people from Facebook, everyone was in the room for whatever systems we were using, right? Amazon. Everyone's all friends on that one day because all everyone's systems have to stay up, right? So it's like a multi-company, multi-internet effort, right? Um, so let me just see what my slide is here. So here's one of the CDNs that's a popular CDN online. This is their coverage globally, right? Um, this is these are the servers that a CDN basically takes a picture of whatever your app is, your APIs or your website, and distributes it to all their other servers, right? So um, it's literally like, I'm trying to think of a good analogy for it. It's like, okay, you want to go to a theme park. That's great. If you go in person, that's you actually going to a server. But if you have a picture of the theme park in your house, that's just as good. So that would be like a CDN, right? Everyone can have millions of pictures of the theme park in their house, but to actually go to it would be kind of a rare instance, right? So any major company that you hit an API with, or a request or a website is being served off a CDN guaranteed nowadays. It's just faster and cheaper. Um, so yeah, they're kind of like photocopiers. They like take copies of your system and distribute it for you. Um, so this, I'm not going to stay on this screen too long, but if anyone's interested, I'll show a link at the end of this presentation. You can really dig into this if you want. This was the architecture in a nutshell. So this is kind of what I do professionally, is kind of design this stuff at a system level. So this is very boiled down. This is not, this is very loose on specifics. But basically, you can see here, you've got your apps here. You've got a feature flag that turns them on the day of. And we have our proxy that turns on our static feeds. And then we have a proxy that turns on our dynamic feeds for API serving. And then that serves it out of our cloud infrastructure. And then we have our playback logic here with a bunch of different CDNs and video providers. So again, I'm not going to get into like super specific on this. I've written an article on Medium you can actually read that goes more in depth into this if you really want to get into the specifics of the architecture here. But some of you may be wondering, okay, this is all cool, but like, what do you guys actually use? So to do all this. So this is taken from our tech recruitment team, actually. These are all the technologies we use currently to serve our product. And a lot of these were used, almost all of them were used to serve the Super Bowl, right? So in the main, so for the clients, right, that's kind of, self-reality, right? If you have an iOS app, you're using, Swift. Or if you have a Fire TV app, you're using Kotlin, right? On the back end, we actually, a lot of our services are built in Golang. So that's the Go there. That's Google's programming language. It's very similar to, it's actually really easy to learn if you've learned Python or JavaScript. It's kind of like a combination of both. It's kind of weird, but it's very fast. And paired with some of these other technologies made our APIs very, very, very fast. And let me see here, my next slide. For video, we used a bunch of all these providers here, and then infrastructure, right? So we're spread out across a bunch of different companies and technologies, because we're made up of Fox Sports is made up of dozens of different teams, right? So they all kind of have their own tech that they use. Now there is, we're trying to get everyone kind of use sort of the same thing, but that's part of my job is even if they're using a separate tech, right? These systems have to interface with each other. So yeah, sometimes it's just about the team was established using this technology or that technology, and that's just what they use now. So it's not so much the tech that makes it happen. It's kind of just the way you use it and the way you build with it. So we kind of use everything, to be honest. So I mentioned backups earlier. So the main place where we all were was in Tempe, Arizona, which was actually a few miles away from the Super Bowl, which was in Phoenix, right? In Tempe. So there's literally a fiber optic cable running from the stadium to our data center where we all were. And so this was new for the Super Bowl, and it had backup generators, backup internet, backup food, security, everything, right? It had its own Starbucks, which is really cool. So this is where all the kind of primary crew met for just the engineering side as well, the digital side, as well as the broadcast side. So everyone that was doing the broadcast stuff was basically in another room beside us. So the backup to this backup was we had an entirely different crew in Los Angeles. If you've ever watched the movie Die Hard, our offices in LA are in the Nakatomi Tower there, which is also known as Fox Plaza now. So we actually work on the third and fourth floors where they filmed a lot of Die Hard. But anyways, so everything was backed up there as well. So we had an entirely secondary crew in LA ready to take over if for some reason this went down, right? So everything's got a backup like an aircraft. So we even had a backup crew, and then there was even another backup to this in India. So we had multiple backups with multiple people from different companies all in our room just in case, right? So just some stats on it as I kind of wrap up here. It was most streamed US event at the time. 7 million plus concurrence. And let me just actually define a concurrent here. What does that mean? So if you're all building an app right now in college, right? If you build a website or an app, right? And you hit refresh once, and you have one call on that page, right? That's one request per second, right? Now, if you think about if you were going to take your app that you made in school and you were going to scale it out to 7 million people using it, that was for us was around 10.5 million requests per second. So that's 10.5 million people hitting refresh on your app all at the same time, right? Or sorry, if you had one call, right? Most apps have multiple calls, right? So if you load a web page, it could have 20 to 300 calls on it. But so if you think about that, right? How many people could your laptop serve your app out to? Or if you think about it that way, right? So, we had about, just for the APIs alone, 4,000 servers, right? Which are high-powered, dedicated servers that have one purpose in life, which is to serve you a JSON response. So just to kind of give you an idea of the scale, right? And that's how I always just like to think about it is okay, I've got this little HTML doc on my computer. If I hit refresh once, that's one of these. So Um, so what was also cool about it is that Fox is the only one to stream in ultra high def in HD, and it's still the only one too. So not only did we have to do bigger and better than the previous year, but we have to do it in HD, which, if you think about it, is much larger of a stream than regular SD. Um, Crazy stat this year was that we streamed it faster than over-the-air broadcast. It came out afterwards. So if you were watching on an app, that was actually getting to you faster than satellite, which has never been done before for the Super Bowl. And then there was no downtime. There was not a single blip or flub as far as the streams going down or the app's not loading. And then yeah, we hit a peak of 10.5 million requests per second. And when we were testing it, we actually tested it up to 100 million requests per second. So this system we designed could go on for years if we really wanted it to, right? Based on that chart of growth. But it was kind of a one and done thing, right? We built it to kind of supplant our end of life system. So not every company is going to do it this way. They have more up-to-date systems that could take the brunt of the impact, more modern systems, and we'll be in that boat next year. But yeah, we knew we built something pretty powerful. This was actually one of the largest load tests that had ever been, I think, done. Generating 100 million requests per second is no easy feat. So there was a whole team just dedicated to figuring out how to do that too. So here's a dashboard I made for the game for the executives to see kind of what our systems were doing. So I just took this in the heat of the moment. You can kind of see our cache efficiency, and we had one dynamic endpoint that was serving up the videos. And the reason we had that was so we could have it choose which CDN you were serving it from. So we actually did not want to cache on that. So we could switch CDNs very easily. So we wanted 0% on that, which is what it was. And then all the API calls that would load the app and load the pages on the website, et cetera, had a 99.69% cache efficiency. So you can see some of the CDNs here in this 4-hour period. We're serving up millions of responses. And you can kind of see here also, average response time. And then also, when the game starts here, right, you see the spike from both CDNs of everyone logging in. So that's kind of a whole solution you got to figure out how to solve too, is you've got all the people watching, but you've also got this tidal wave that comes in, right? So that's a whole different strategy of how do you solve for a tidal wave. Here's some pictures of me just in the Tempe broadcast center, so you can kind of get an idea what I was dealing with. So this little amphitheater here is actually where all the digital folks were. So you can kind of sort of see it in the screen picture, but you can see all these different TVs that are set up. These are all the different apps, right? Roku, Fire TV, Samsung, Apple TV. They are all up separately, and we could switch between different locations in the country. Then we had some, dashboards up and live feeds, so we could see how many people were concurrently watching, et cetera. And then everyone in the rooms from all across the United States, and different companies helping us out, right? Like all the providers that we use, and all the engineers. And this is the broadcast center. It's brand new. It's a really cool place to go. And then, in the back, that's where they actually broadcast out of for any Fox Sports game that you would ever watch, or Fox broadcast channel thing. And then, yeah, this was actually, I think this was during the game. So you can just see how active it was with people kind of honed in on their computer screens. And I was kind of in this little kind of like silo blackout room on the side, because we were responsible for serving out all the APIs. So it was just a team of 4 of us. And I was kind of, making some shots there. And then, yeah, after the game, nothing had gone down. So we're all really happy, and it was really cool and fun. And this is the primary team here, just to give you an idea of how many people work on it. Um, this would be engineers, product, program, designers, directors, managers. So this is what it took to stream it for that one day, for that one 5 hour period. This is all the people it took to make sure it didn't go down. So yeah, so that was my experience with it. I know I didn't get too much in the technical details. If you want to know some of the technical details, you can go here. Let me see if I have this open. And share my screen here and kind of see. So here we have a Fox Tech site, and you can see everything I kind of mentioned before. And you can click here. It says behind the scenes, part 1 and part 2 of the Super Bowl. And I wrote the second part, which is all about the technicals. So it gets a lot more into detail on the architecture and the testing behind it, what tools we used, different concepts for testing, etc. And then the first part of the article talks about more the product side and the marketing side, and how we simulated it and how we ran the management side of it. And this, my friend here, Chris's experience doing it. So, and then also, if anyone's interested, all the jobs are posted here too. So Fox Sports is hiring a lot. You can see there's 63 jobs currently posted. So